Okay, so we have how many of these molecules are polar? We have SO3, OF2, BeCl2, CCl4, and O3. To figure this out, we have to do three things. First, we have to draw the Lewis structure. Second, we have to identify the bond dipoles using differences in electronegativities. And third, we have to identify the net molecular dipoles based on molecular geometries. Okay, so first we have SO3. The least electronegative atom goes in the center, so we have SO3 right here. So then we have 3 O's on the outside. So then we have to do valency electrons. So we do 6 plus 3 times 6 equals 24. So then we subtract the bonds. 2, 4, 6. Subtract, you get 18. So then you make octets on the outside atoms. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So now we have to make sure they're all octets. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. 2, 4, 6. So S does not have an octet, so we have to move electrons from an O to double bond to the S. And this is a resonance structure because you can do it to any O to make it a double bond. Okay, so now we have to identify bond dipoles using electronegativities. So if you look at the chart, O has an electronegativity of 3.5 and S has 2.5. So because O is more electronegative, the negative head will go towards O and the positive tail will go towards S. So we have a bond dipole right here, bond dipole right here, and bond dipole right here. So then we have to do the net molecular dipoles based on molecular geometry. So we have 1, 2, 3 domains with 0 non-bonding. So that gives us a trigonal planar. And because the 3 domains are the same, the bonds cancel, so that gives us a nonpolar molecule. So SO3 is nonpolar. So now we have OF2. First we have to do the Lewis structure. So least electronegative, O in the center, F on the outside. 6 plus 2 times 7 equals 20, minus 2, 4 over here, so it gives us 16. So octets, 2, 4, 6, 8, 10, 12. So we have 4 left over, so we put it on the central atom. So now we have to count 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. So they all have octets. So now we have to do the bond dipoles. So F, of course, is the most electronegative, so it has the partial negative, partial positive. The negative head pointing towards F, positive tail pointing towards the negative F. So now we have to identify the net molecular dipoles based on molecular geometries. So we have 1, 2, 3, 4 domains plus 2 non-bonding will give us bent. So we draw that out. 2 non-bonding over here, F over here. Positive tail, negative head. So the net molecular dipoles, because the domains are not the same, we will have that, and it's going to be pointing downwards. So that gives us a polar molecule. OF2 is polar. So now we get to BeCl2. Lewis structure, least electronegative on the center. Cl is the most electronegative, so partial negative and partial positive on Be. Valency electrons gives us 16 minus 2, 4 gives us 12. So octet on the outside first. 2, 4, 6, 8, 2, 4, 6, 8. But Be does not have an octet, but we know that it's okay because it is a violation of the octet, so it doesn't have to have a octet. So now we do the dipoles. Positive tail, negative head pointing towards Cl. Positive tail, negative head pointing towards Cl. So we have 2 domains with 0 non-bonding around Be, so that gives us a linear molecular geometry. And because the 2 domains are the same, the bond dipoles cancel, so that gives us a nonpolar molecule with no net molecular dipole. So BeCl2 is nonpolar. So we have CCl4, so the Lewis structure. C is the least electronegative, so that goes in the center. Valence electrons, you get 32 minus 2, 4, 6, 8 gives us 24. So then we put them around 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we make sure we have octets, which we do on all 5. So now we do bond dipoles. So Cl is a partial negative because it's the most electronegative. C is a partial positive. So the partial positive tail will be pointing towards C for all of them, and the negative head will be pointing towards Cl. So now we find the domains. We have 1, 2, 3, 4 domains with 0 non-bonding around C. So that gives us a molecular geometry of tetrahedral. And because all 4 are the same, the bonds cancel, and that gives us a nonpolar molecule with no net molecular dipole. So CCl4 is nonpolar. Okay, so lastly we have O3. So they're all the same atom, so we recognize that. So it doesn't matter which one's in the center, so you just do it. Now we have valence electrons. We get 18 minus 2, 4, 14. So we do outside first, of course. 2, 4, 6, 8, 10, 12, 14 because left over. Now we have to check octet. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6. Okay, so the center atom does not have an octet, so we have to move electrons from one of the O's to make a double bond. And it doesn't matter which one, just pick one because they're all the same. So this is what we will get. O, 2, 4, 6, 8, octet. 2, 4, 6, 8, octet. 2, 4, 6, 8, octet. So because they're the same atom, there are no dipoles, because in electronegativity, if you would subtract it, you would end up with 0. So then we have to find the domains. So we have 1, 2, 3 domains, but we have 1 pair non-bonding. So that gives us a bent, which would look like this. And because all 3 domains are not the same, then it's polar. So O3 is polar. So now we have to go back to our question. So how many of these molecules are polar? SO3, nonpolar. OF2 was polar. BeCl2, nonpolar. CCl4 was nonpolar, but O3 was polar. So we have a total of 2 polar molecules out of these 5. So common mistakes, we have to correctly draw out the Lewis structures. We have to recognize the octet, and we have to know the violators of the octet, because if we don't do that, our results will not be accurate.